I'd have to go in and I'd have to put in all the stuff. But geometry lesson 25, triangle congruence. We're talking about side, side, side. For you guys, this is going to be, for some of you, this is going backwards a little bit in terms of stuff that you know. But talking about triangle congruence, what does the term congruence mean when we're talking about shapes? Same what? Same size and same shape. And so in addition to that, we know that the corresponding angles are congruent and the corresponding sides are congruent, correct? So, but we don't always have all the information, and we really don't need all of the information. We just need specific information to be able to prove that, in this case, two triangles are congruent to each other. And so what we're talking about today is that if three sides of a triangle are congruent to three corresponding sides of another triangle, then those two triangles are congruent. And in terms of our triangle congruency postulates, we have like angle, side, angle, 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 side, angle, 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 side. I'm trying to think of the ones I've said. Have I said side, angle, side yet? No. And side, side, side. So one thing that's common about all triangle congruency postulates is that they'll always include at least one side. If I ever say angle, 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 all I've proven is that those two triangles are similar, but I haven't proven that they are congruent. Okay? All right. So corresponding sides and corresponding angles of polygons are those that are in the same position in two different polygons with the same number of sides. These corresponding parts are indicated by the names of the polygons. Okay? But we spend a lot of time with triangles because all of your other polygons are going to break down into triangles. When naming congruent polygons, it's important that the order of the points or vertices in the names correspond. So whenever I say triangle ABC is congruent to triangle DEF, angle A and angle D need to be the same, okay, because they're corresponding in my order. So if I'm going A, B, C, D, E, F, I need to make sure that A and D are congruent, B and E are congruent, C and F are congruent, if I'm going to use that order. Okay, does that make sense? Okay, corresponding, so it's in how we label things as well. Triangles are said to be congruent triangles when all of their corresponding sides and angles are congruent. One way to determine if two triangles are congruent is to use the side, side, side congruency postulate. It's not the only congruency postulate, but it's the one that you're learning today. Okay? So they're calling it postulate B, or side, side, side congruency postulate. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent to each other. Because of the relationship that angles have with sides in a triangle, it forces even those angles to be congruent to each other. It's got to be the same size. It has to be the same shape because it's forced into that situation. Next thing that we see is something called CPCTC. Okay? Some of you are beginning to see just how much overlap there is between Algebra 3 and geometry. It's a whole lot of overlap, right? So if some of you are planning on taking Algebra 3 in the future, you're going to have a little bit of an advantage from the standpoint that you're going to be a little bit more equipped for Algebra 3 because there's a lot of stuff that we talk about that comes from geometry. If you're in Algebra 3, you have an advantage in geometry class because you've already talked about this stuff, so it helps out here. But corresponding parts of congruent triangles are congruent. I have to know that two triangles are congruent before I can say that their corresponding parts are congruent. I cannot put CPCTC ahead of a congruency statement, okay? Because by definition, I have to have already known that those two triangles were congruent to begin with. Okay, does that make sense? So when we start to work out proofs where we're proving that two triangles are congruent, and I'm putting everything in order, right? If I ever see CPCTC show up before, let's say, side, side, side congruency postulate, then it's automatically wrong because I can't, it gets out of order, right? The order is important there. So when two triangles are congruent, CPCTC states that all the corresponding angles and sides of those triangles will also be congruent. For example, if we have triangle ABC congruent to triangle DEF, okay, let's just go ahead and, okay, A, B, C, okay, let's do a better job here. Okay. DEF, granted, I know that they don't look congruent, but we're just using this for a visual. We're going to say that if I know that these two things were congruent, then I know their corresponding parts are congruent. So A is going to correspond to D. Okay, B is going to correspond to E. And C is going to correspond to F. And then we could go in and look at tick marks. So AB would be congruent to DE. BC would be congruent to EF. AC is congruent to DF. Okay, do we follow that? Once I know that they're congruent, I know that all of those corresponding parts are congruent. Okay, so we should be able to, when we start to look at this, once I've proven that two triangles are congruent, I can write up to 6 possible congruency statements. Okay, because I have 3 sides, right? So I can have 3 sides congruent to 3 sides, and I have 3 angles that can be congruent to 3 angles. So 3 and 3 is 6. Okay, questions? Okay. There you go. All right, so from here, let's look at some questions. Okay, some of this is just strictly going to deal with being able to write congruency statements in correct orders. So they tell me in triangle LMN, LM is 10, MN is 15, LN is 20. In QRS, QR is 20, RS is 10, QS is 15. We want to write the congruency statement for the triangles. We want to show the correct order. So if they're telling me LMN, I want to know what letter corresponds to L, what letter corresponds to M, what letter corresponds to N. What's the best way to start this to be able to know for sure? Chandler, draw. Okay, a couple people, draw it. Okay, so L, M, N. Okay, let's do Q, R, S, because we would like to assume that that LMN is in order in terms of alphabetical order, QRS is in alphabetical order, so L is going to correspond to Q, M is going to correspond to R, N is going to correspond to S, right? That's what we would naturally assume, but we can't assume. We have other information that we can put in. All right, what is the length of LM? 10, okay. MN, 15, and LN, 20, okay? Let's come over here. What is QR? Okay, all right, so we already see a problem, right? LM doesn't correspond to QR. Okay, what about RS? 10. Okay, what about QS? 15. Okay, so what I'm going to do is I want to know what corresponds to L. Okay, see how L shows up between 10 and 20? Can we see that? Okay, I want to look over here and I want to see what is between 10 and 20 on my other triangle. R. Good. Okay, so L corresponds to R. Okay, what corresponds to M? Well, where is M? What is M between? 10 and 15. So I want to see what's between 10 and 15 over here. Okay, 10 and 15. Okay, so we got M, S, and we only have 2 things left, right? So I can go triangle LMN is congruent to triangle RSQ. RSQ. Okay? If we follow that process, we understand how to use some logic to get where it is that we want to go. Okay? All right. Okay? Number 2, this tells me that my 2 triangles are congruent. It tells me that A corresponds to M. It tells me that B corresponds to N. It tells me C corresponds to O. Correct? All right, so we have, you'll notice, 6 congruency statements, right? All right, so we know that angle A corresponds to what? M. So I have 3 options, right, for A corresponds to M. Okay. What does B correspond to? N. Okay. That gives me two options, right? What does C correspond to? O. All right. So far, still two options. Okay. What does AB correspond to? MN. Does that give me my answer? Yeah, because the other one is AB to MO. And we would see that all the rest of this is true as well, right? Okay. Okay, so be careful because they're going to look pretty similar throughout. You got to make sure that the correct answer is the correct answer all the way through. Okay. Determine whether the triangles are congruent. What do you think? Are they congruent? Chandler, why not? Right, we have a difference between 17 and 16. Now, 20 matches with 20, 24 matches with 24, but it's got to be, it's not side, 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 right? It has to be side, side, side in order for them to be congruent. So our answer is A, not congruent. Okay. I would say 20 equals 20, 24 equals 24, 17 does not equal 16. Therefore, these two triangles are not congruent. Okay? That was a good question. The question was, how can we show that, our work on that question like that? Let's look at this. Let's see, Jose, are these two triangles congruent? Yes, okay. I see a 30 here. Do I have a 30 on the other one? Okay. I see a 31 here. Do I have a 31 on the other one? Okay. I see a 15. Do I have a 15? Okay. Is that enough to prove it? Yeah. So we're going to say congruent. Okay. And our work there would be 30 equals 30, 15 equals 15, 31 equals 31. I've got three sides, side, side, side congruency postulate. Okay. Let's see, we don't need to do number 5. It's a justification question. It would be good practice, but we don't need it. Let's see. Number 6, identify the congruent sides and angles of the two triangles below. We want to write 6 congruency statements. All right, let's start with angle Q. Angle Q is congruent to angle what? Angle V. Okay, angle S is congruent to what angle? U. Okay, angle R is congruent to angle T. Okay, so we got that. What do we need to do next? Sides. Tell me how to write that. SR. Okay, SR with a line over the top of it, right? Is congruent to what? SR is congruent to what? UT, right? Okay, and we understand why we're not writing that as TU, correct? Okay, good. All right, what's next? Let's see, Katie, give me another side. We have SR, SQ. Okay, what is SQ congruent to? UV. Okay. All right, let's see. Chandler, give me another one. QR. VT. Okay. We feel like that's fairly simple to do. Shouldn't have any problems with that. Okay, good. All right, number 7, I says identify the corresponding angles and sides for triangle ABC and EFG. That's the same thing. I'm not going to go through that again. It's the exact same process that you just went through on number 6. Okay. Write a congruency statement for the two triangles below. So triangle, what? ABC, okay. Triangle ABC is congruent to triangle what? XYZ. That's it. Okay, does this feel like a really easy lesson so far? at least these seem like easy questions. Doesn't mean that the questions in the book are going to be quite this easy. And that looks like that is that for that. So what I'm going to do, I'm going to hit stop on this, get the recording sent out to you, and walk around and help you guys out with your homework if you need it. Give me a second.